Today we'll explore how data is spread out and how we can use different tools, statistical tools like range, quartiles, interquartile range, and percentiles to measure this spread. Before you begin, I want you to think about this. Imagine you and a group of friends running a race and you guys all finish at different times. The fastest person maybe finish in 10 minutes and the slowest person finishes in 30 minutes. Other people finish somewhere in between. Wouldn't it be useful to describe how spread out the finishing times are? Are all runners close in time or are there huge gaps? This is where measure of spread help us. They tell us how dispersed or how clustered data is around the center. The main tools we use today are range, quartiles, interquartile range, and percentiles, each giving us a different way to look at data distribution. The range is the simplest measure of speed. It tells us the difference between the highest and lowest value in the data set. The formula is really simple. Range equal to the maximum value minus the minimum value. Going back to our earlier example, the fastest person took 10 minutes, the slowest person took 30 minutes. So the range equal to 30 minus 10 equal to 20 minutes. This means that the finishing time of the runners are spread across 20 minutes. But is this enough information? Not really. If everybody but only one person finished between 10 and 15 minutes, and one slow runner still took 30 minutes, the range will still be 20 minutes, but it doesn't truly represent the data. We need a better way to see how most of the value are distributed. Alright, let's move on to the topic quartiles. Let's have a quick recall of the term median. The median is the middle value of a data set when you arrange the data set in ascending order. Let's take a two example. Let's say you have this odd number of values in this data set, 3, 7, 9, 12, 15. Clearly you can see that 9 is in the middle of the list, so 9 is the median. But if you have an even number of values, for example, if you have 3, 7, 9, 12, 15, 18, then the median will be the average of the two middle numbers, which is 9 and 12, which give you 10.5. In this case, the median is also called the 50 percentile because you can think of it as 50% of the data are higher than it and 50% of the data are lower than it. The median is also known as the second quartile. For this sorted finishing time in minutes 10, 12, 14, 16, 18, 20, 22, 24, 26, 30, you can count them and realize there are 10 elements. So since there are 10 elements, the median will be the average of the two middle values, which is 18 and 20. So the median will be 18 plus 20 divided by 2, gives you 19. Next, we can try to find the lower quartile, also known as the 25th percentile, also known as the first quartile. This means the 25% of data fall below this point. The easiest way to think about this is to take the data set you have, you split into half, two equal half, and then you take the median of the first half. That will give you the lower quartile. In this case, if we split our 10 elements into half, we have 10, 12, 14, 16, 18 in the first set. And so the lower quartile equal to the median of this set, which gives us 14. Similarly, for the upper quartile, let's take the second set, which is 20, 22, 24, 26, 30. It has 5 elements, and so the median of this set is 24, which is equal to the upper quartile. The upper quartile is also known as the 75th percentile and also known as the third quartile. So let's see what happens if we have a data set that has an odd number of values. In this example, we have 1, 5, 7, 9, 15. The median in this case will be the middle of the list, as the dataset has an odd number of values. Therefore, the median is 7. Now let's split the elements into two sets. You can see that as this list has odd number of elements, to split into two sets, we first have to remove this median value. So let's remove 7, and now we have two lists, 1 and 5 and 9 and 15. To find the first quartile or the lower quartile, especially the median of the list 1 and 5. And the median of this list is just the average of these two numbers, 1 and 5, which give us 3. And to find the upper quartile or the 75% quartile, sorry, I meant the 7 percentile, is basically the average of 9 and 15, which gives us 12. Now, let's move on to the interquartile range. This is basically measuring the spread of the middle 50% of the data. And we can simply evaluate this by taking the upper quartile, also known as the 75 percentile, minus the lower quartile, also known as the 35 percentile. In this case, we have the upper quartile, which is 34, minus 14 equal to 10. This means that the middle 50% of the runners finish within a 10 minutes range. Interquartile range is useful because, unlike range, interquartile range ignore outliers and focus on the majority of data points. What does it mean by ignoring outliers? Note that for this example, we know that the range is 30 minus 10 equal to 20, and the interquartile range is equal to 10. But let's change the last element, 30 minutes to 100 minutes. Assume that someone, maybe he just slowly walk and crawl for the whole race and take 100 minutes to finish the race. With this new sorted finishing time, the range is now 100 minus 10 equal to 90. But the interquartile range is still the same. Previously, we have already mentioned and used this term percentile. So now let's formally define this. A percentile tells us what percentage of data fall below a particular value. For example, 75 percentile means that 75% of the data is below this value. This is also known as the upper quartile. The median is actually the 50 percentile, which means that 50% of this data is below this value. And how can we use this in real life? In standardized tests, like your exams or the SAT, if your score is in the 90 percentile, that means you score better than 90% of the test takers. Hospital also use percentile to compare baby weights. If a baby is in the 60 percentile for weight, that means 60% of the baby are lighter than this baby. Now, back to our original example of the sorted finishing time. If a runner finishes in 23 minutes, what percentile are they in? Take a minute to think about this and pause the video. Now, you can see that 23 minutes is between 90 minutes, which is the medium, and also less than 24 minutes, which is the 75 percentile. That means the runner is above 50 but below 75%. Probably around 60 plus percentile. For us to know exactly which percentile they are at, we can do this with a cumulative frequency graph, which we will show later.